Good morning, Algebra 2 students. I'm going to be explaining to you how to graph radical functions today. This follows along very much like the other functions that we've graphed. So we're going to do this by translation, and you already know these translation. You know plus k means up or down. You know that minus h means right or left. And you know that the a factor in front means a vertical stretch or compression. You know all these things, so this should not be too difficult. So the first thing I want to point out to you is that our function form for our square root function looks like this right here. So f of x equals a times the square root of x minus h plus k. And if you look below here in the box, we have all the different translation. So here is our parent function. If you have a negative in front of the parent function, it reflects it on the x-axis. If you have an a in front of the square root, that is going to be a shrink or a stretch factor. Keep in mind, it is a stretch factor if it is greater than 1, and a shrink factor if it's between 0 and 1. And translation's horizontal by h. Remember, if you have minus h, it's going to the right. If you have plus h, it's going to the left, same as before. Plus k is going up, minus k is going down. And over here, you can see the same thing for any radical. So it could be a third root, a fourth root, a fifth root, whatever it is. Here is a graph from Desmos of our parent function y equals the square root of x. And what I do want you to notice about this is this, if you look closely, is half of a parabola on its side. And so it has some of the same features as our quadratic parent function y equals x squared, except that it's on its side. So you'll notice right here, this is like your vertex. If you go 1 up and 1 over, you've got a point right here. If you go 2 up and 4 over, you've got a point right here. So it has the same features as our quadratic function, but it's on its side. Notice that the domain of the function, that means the x value, so let's write that out here, the domain of this function, and that's our x values, is going to be x is greater than or equal to 0. And if you look at your graph, notice there is no graph to the left of the y-axis. Now when we look at our range, and we'll write that down, and these are our y values, on our y-axis, note this, the range is y is greater than or equal to 0. This entire function, the parent function, is graphed right within quadrant 1. Here we're going to graph a couple of radical functions which happen to have vertical shifts. So let's take a look at the first one we're going to do. We'll do this one in pink right here. Underline it in pink. This is our parent function shifted down 2 units. So notice what we said before was the vertex would end up going down 2 units. We'd go up 1 over 1 and up 2 over 4, and that would give us the general shape for our function. So let me draw that in here by hand. Looks something like this. And let's go down here in blue, and we'll do y equals square root of x plus 1. That's a shift up of 1. So it's going to start right here, up 1 and over 1 from there. And from our original point, up 2 and over 4 puts it right there. And there is our function. Let's go ahead and graph some horizontal shifts. Let's take a look. Let me get the pink pen up here. And we're going to do this one. And notice this is plus 4, so this is a shift to the left 4. So we're going to start our graph right here, do our up 1 over 1, go back to the original point, up 2 over 4, and that'll give us a nice basis for our graph. Now, let's go ahead and do the other one. Since this is -1, this is a shift to the right one. So it's going to start right here, go up 1 over 1, go back to the original point, up 1 over 4, and that'll give us a nice graph right here. So let's go ahead and graph a couple of functions that have multiple translations in them. So first of all, let's go to A. And in A, let's see what color we're operating with here. We'll do blue. Notice that we have a horizontal shift right here, 3 to the right, and a vertical shift up 1. So 3 to the right and up 1 is going to put the edge of our graph right here. And we've also happened to have a compression factor right here of 1/2. Now keep in mind, even though this is like a half of a parabola on its side, a compression factor makes this go wider on the x-axis. So it actually makes it skinnier sideways as opposed to looking fatter. So from here, we're going to go up 1/2 and over 1. And then we're going to go up 1 and over 3. Very, very skinny. Barely has an arch to it at all. So if you go over here to example B, and what we'll do, we'll shift here to pink, we notice that we have a horizontal shift. +2 is 2 to the left. -4 is 4 down. So 2 to the left and 4 down. Going to put that beginning spot right there. Now, this is actually going to get, it's going to look kind of fat, but really what it is a vertical stretch. So when we do this, we're going to go up 3 and over 1. And then we're going to go up 6 and over 4. So let me see if I can count that up here, right? So that actually makes this look quite fat, but really it is vertically stretched. Now I just want to mention something. We'll talk about this one particular graph as an example. If I want to know my domain again is my x values. And notice the x values, it goes from -2 to the right, so its x is greater than or equal to -2. And the range of my graph, and you get this just by looking at it, my range, this goes from -4 all the way up to +infinity. So y is greater than or equal to -4. Next, we're going to graph a cube root function, and keep in mind, once again, this cube root function is very similar to our cubic function, but again, it is rotated onto its side, and you can see the parent function, y equals the cube root of x, right here. And what we're going to do is we're going to graph some translations of that. So if we go to example A, you can see we have a shift 1 to the left, and I'm going to start with right here on my graph, 1 to the left and down 4. So 1 to the left and down 4 puts that center spot right there. Now, I also have a vertical stretch. So instead of going 1 up and 1 over, I'm going to have something a little bit different. From here, I'm going to go up 2 and over 1. And in reverse, I'm going to go down 2 and to the left 1. And you'll see that what I end up having is something shaped somewhat like this. Now, if we take a look at example B, this might be confusing because you see the 3 right in front of the whole thing. If it helps, let's switch to blue here so we got a new color. Don't put the 3 there, add it to the end, and now if it looks like a plus K and helps you out, you're just rearranging it. We can do that in algebra. So if you take a look at our translations, we're going to go 2 to the right and 3 up. So 2 to the right and 3 up is going to put our center point right here. Now, one thing you need to notice when we go to start graphing our points is we have a negative right here. which is going to flip this thing about the x-axis. And so what's going to end up happening is that instead of having the shape of the pink one that you see on the left, it's going to look more like this. And it's also going to have a compression factor, vertical compression of 1/2. So here's what I'm going to do. Go from my point, go up 1/2 and 1 to the left. Go down 1/2 and 1 to the right. And you'll see I've got something that's going to look somewhat like this. The last thing we're going to do today is use a little bit of algebra to rewrite some radical function equations so that we can better graph them. Because if you look at this one, y equals the square root of 9x plus 18, this is really confusing, having that 9 right in front of the x. That's not in our form of, let's see, we'll write it down here at the bottom, of y equals a times the square root of x minus h plus k. And the reason it's not like that is because there's something in front of the x and we don't really know what to do with that. So what we're going to do is use a little bit of algebra. What I'm going to do first is just look at my 9x plus 18 and notice that I can factor a 9 out of there as a greatest common factor. And so what that's going to give me is this, y equals the square root of 9, and when I factor it out, that gives me x plus 2 in parentheses. Now, I can use my product rule for square roots and write this as y equals the square root of 9 times the square root of x plus 2. And the square root of 9 is 3. So this gives me y equals 3 times the square root of x plus 2. And now you can see that we are going to have a horizontal shift 2 to the left, and we're going to have a vertical stretch of 3. So let's try this one more time, but we're going to do example B with a cube root, and we're going to do the same thing. We're going to go inside that cube root, and we're going to factor out an 8. So I've got y equals the cube root of 8, and then in parentheses, that's going to give me x plus 4, and then minus 2. And again, I'm going to use that product rule on my cube root. And now I can simplify the cube root of 8 to be a 2. And notice I now have a function that is in a format where I can see all my translations and go ahead and graph it.